Hello everyone. In last session we have solved some problems based on sphere, and today we are going to find out the condition where the plane touches the sphere tangentially, and we are also going to figure out what must be the point of contact here, right? Now here in the question what they have given, there is some plane. We want to show that this plane touches the sphere tangentially, and we are going to figure out the equation, right? What are the given things? So we have one sphere, plane is given, and so plane must intersect the sphere, and we need to show that this plane touches the sphere tangentially, right? So how to show that? What we are going to show that is, if plane is tangential to given sphere, that means it's when I'm drawing perpendicular from center to plane, it works as a normal to the plane, and this distance I am going to show that this perpendicular distance which is drawn from center is nothing but radius of the sphere. If the perpendicular distance is a radius, then that plane must be tangential to the given sphere, right? So just write down this condition for now. That is, if plane is tangential to a sphere, if plane is tangential to the sphere, if the perpendicular distance which is drawn from center of sphere, for example I am drawing from here C to center of sphere to plane, is equal to a radius of sphere, right? So for that I need to figure out, first of all, using equation of sphere, what must be the center of sphere and what is the radius, and then we are going to figure out this perpendicular distance drawn from C, right? And let's consider the point of contact for now as P only. Okay, so let's start with the equation of sphere here. This is given, and sphere is x square plus y square plus z square minus y minus 2z minus 14 is equal to 0. So what is center? Center is general equation of sphere, so center is minus u minus v minus w, that is the coefficients of x, y, z divided by 2 with negative sign. The coefficient of x is not present here, so that means first coordinate must be 0. Coefficient of y is minus 1 which divided by 2, and here already I am considering negative sign, so this is just 1 by 2, and the coefficient of z is minus 2 divided by 2 minus 1, and already minus sign is there, so 1. So this is my center, right? And let's find out radius as well. What is the radius? Radius is square root of u square plus v square plus w square minus t, right? U is 0, so this is just v square is 1 by 4 plus 1, and minus of minus 14, so this is just plus 14, right? Add this together, so I'll get this as equal to 1 plus 4 plus 56 divided by 4, so this is root of 61 divided by 2. So radius is equal to this. So we are going to show that the perpendicular drawn from this length is nothing but radius, right? So let's figure out the length of perpendicular. The formula for length of the perpendicular we have already discussed in the theory. Length of perpendicular drawn from point center. Center is 0, 1 by 2, this to the plane. Plane is 4x minus 3y plus 6z minus 35 is equal to 0. So perpendicular distance is given by 4 into, here I am going to substitute the 0, half and 1 point. So 0 minus 3 into half plus 6 into 1 minus 35. And this is divided by square root of 4 square plus 3 square plus 6 square. That is coefficients of x, y, z. That is 4 square plus 3 square plus 6 square. And this is equal to minus 3 by 2 plus 6 minus 35. This is divided by square root of 16 plus 9 plus 36. And this is equal to, this is minus 3 plus 12 minus 70 divided by 2 into root 61, which is, this is again mod of 61 to root 61. So this is same as just multiply and divide by root 61. So 61 get cancelled, so which remains with root 61 by 2. And this is equal to radius, right? So that means my conclusion here is that the length of perpendicular is same as radius. So that means given plane is tangential to sphere, right? Now it is tangential to sphere, there is a point of contact. We are going to figure out now point of contact, right? Now to find out this point of contact, the first thing we are going to figure out the equation of CP. See, CP serves as normal to the plane, and I know that in the equation of plane is 4x minus 3y plus 6z. In this equation, coefficients of x, y, z are nothing but direction ratios of normal to the plane, right? So that means I have direction ratios of CP, and I know CP is passing through the point C. I have coordinates for C also, so I can figure out equation of line CP using this point and the direction ratios, right? So let's figure out this. So equation of CP, to find point of contact, let's find equation of CP first. Equation of CP. Now CP is normal to the plane and it passes through center C, that is 0, half and 1. Therefore direction ratios of CP, these are nothing but coefficients of x, y, z in the equation of plane. So that is 4 minus 3 and 6, right? So therefore equation of CP is x minus 0 divided by 4, y minus half divided by minus 3, and then z minus 1 divided by 6, right? Now using this equation, I am going to figure out what must be the general coordinates of any point which lie on this line CP, right? So to do this, I am going to consider this as K, right? So therefore, what is x? X is nothing but 4k. What is y? Y is minus 3k plus half. What is z? Z is 6k plus 1, right? So these are the coordinates of any point which lying on the line CP. So in particular, I got point P also, since P lies on CP. So therefore, coordinates of P directly I can conclude as 4k minus 3k plus half and 6k plus 1, where P is a point of contact. P is point of contact, right? Now note that this point of contact lies on the plane. So you can observe from the diagram, this point of contact is lying on the plane. So that means it should satisfy equation of plane. So this fact I am going to use to figure out value of K. Okay. So since P lies on the plane, so it satisfies equation of plane, correct? So therefore, what do we have? 4 into 4k minus 3 into minus 3k plus half plus 6 into 6k plus 1 minus 35 is equal to 0. Simplify this equation to figure out value of k. After simplification, I am going to get value of k is equal to half, right? Once I get k, it's not difficult to figure out point of contact. You need to just substitute value of k here. So therefore, what is P? P is substituting half here, so 2, and minus 3 into 1 by 2 plus half, 6 into 1 by 2 plus 1. So this is 2, then minus 1 and 4. So this is my point of contact, and that's it.